This last video is to help you review the waves final. So we're going to take a look at question 51. Label or draw the following on the wave pattern below. All right, amplitude is the first thing we're going to label. Amplitude is the distance from the equilibrium or the middle line to the top of the wave or the bottom of the wave. It could be here, it could be here. Those are all amplitudes. Crest is the top of the wave. This is a crest, and B is a crest. Trough is the bottom of the wave. There's only one of those marked, and it's right there. Cycle would be one wavelength, or one repetitive motion. So a cycle would be from A all the way to E, because right here is where the wave starts over with the same motion that it started with. So right here is where the wave or a cycle ends. The next goal is to find frequency from period and period from frequency. So the period, the formulas are 1 over frequency. Period is the time it takes for one wave or one cycle to happen. Frequency is basically how often they happen. And the formula for that would be 1 over period. So if the period is 20 seconds, what's the frequency? So this equation is going to be most useful for us because we're looking for frequency. So it's easiest to just plug in your time for t. So 1 over 20 is going to give me my answer. So 1 divided by 20 is 0.05. So the frequency would be 0.05, and the units for frequency are hertz. The frequency is 200 hertz. What's the period? So now I'm going to use this equation. Period is 1 over frequency. So I'm going to take and plug in 200 for my frequency. So 1 divided by 200 is, the period would be 0.005, and period is always in seconds. For the next goal, you're going to identify amplitude and period from a displacement, which is the up and down motion, versus time. So this is time in seconds along the x-axis. So here we're going to figure out the amplitude of the wave is from the equilibrium to the top, so it looks like it's 2 centimeters. The period of the wave, by definition, period is the time it takes for one wave to occur. So if I look at this wave, it's starting here, going down here, that's halfway, and when I end up right here, this would be one wavelength. So this is 0.2, 0.4, 0.8 over here, this must be 0.6 there. So the period of the wave is 0.6 seconds. What's the frequency of the wave? Well, we have to know the formula for that. Frequency is 1 over period, so if I know the period, 1 over 0.6. 1 divided by 0.6 is 1.67 repeating, so that would be the answer, hertz. The next one, you're supposed to figure out the wavelength and the speed if you're given the frequency. So now notice how this graph is along the x-axis, it's distance. This graph up here was time. So you find period from that because it's a time. But from here, we can actually find the length of one wave. Because that's what they're asking. What's the wavelength? It means what's the length along the x-axis of one full wave. So we're going to find the beginning. We're going to find the end. That's halfway. Right here is where the wave is going to start over. So we know this is one full cycle or one full wavelength. And reading the graph, it's 0.4 meters is the wavelength, the length of one wave. If the frequency is 20, what's the speed of the wave? For this one, you're going to need the other equation. Speed equals frequency times wavelength. That funny looking backwards H means wavelength. So we're trying to find speed. We know the frequency is 20, and we know the wavelength from this graphic, we just calculated it, was 0.4. So we're going to take 20 times 0.4, and we're going to get 8. So the speed of the wave would be 8 meters per second. the last thing to do is regarding standing waves. And let me just explain this. This is not as good as the graphs that we've used before, but I think I can explain here. If you guys remember that when you look at a wave like this, we've just reviewed how to figure out how long one wave is. If we look at a wave, it starts here and it's traveling along. We know that one wavelength ends right here. If we were to put a barrier in the way, it would reflect. The wave would actually not go through, it would reflect and would bounce off like this. And so this pattern, when you see that, is a wave that's kind of frozen in between two boundaries. It's what we call a standing wave. This standing wave is said to have two loops, 1, 2. Okay, a full wavelength, in other words, has to have two loops. So if we look at this graphic, there's actually two full wavelengths on here because there's 4 loops. The information they give us is the length of the string, the whole thing from here to here is 6 meters. And I'm going to actually change this because it's going to be easier if we make it 8 meters to explain this. I should have done that. But if we make that 8 meters, go ahead and change it on your paper, then the whole thing is 8 meters in length. The frequency for this one is 20 hertz. What's the wavelength and what's the speed? Okay, so what you're going to do here is we're going to say, all right, we know there has to be 2 loops for one wave. So 1, 2 loops is right here. So the question is, how long is each loop? Well, if the whole thing is 8 and there's 4 loops in it, each one must be 2 in length, right? 2 plus 2, 2, 2, and 2, 2, 4, 6, 8. So one full wavelength from here to here is only 4 meters. What's the speed of the standing wave? Speed is frequency times wavelength. They tell us the frequency is 20 hertz. And we know the wavelength is now 4. So 20 times 4 is 80 meters per second.